for today's agenda, it is like just first we'll start with introduction, then we'll go for the further with the challenges that we face in regular basis based on like AI or ML models, like to how your uh, what are the challenges that we have if we want to run, let's say, if the example of ChatGPT. So if we want to run ChatGPT in a more scalable or a more efficient way, how can we do that? Then why TensorFlow Lite? Then we'll see some models on that, and then we'll see some like examples based on that on device ML solutions with TensorFlow Lite. So in introduction, the first thing is why we need. So as of now, we are talking mostly about TensorFlow Lite. So here the thing is that why we need TensorFlow Lite and when do we need it? That is the first question, right? So we already have TensorFlow. Let's say if I talk about Facebook. So Facebook is having Facebook Lite, and let's say Zepto. So Zepto is having Zepto Lite. So multiple applications that they have. So they have a Lite feature as well. Sorry, Lite application as well, right? Which is basically those applications that you use like Facebook Lite or Zepto Lite or Flipkart Lite. In case of these applications, they just what is the actual purpose of having those applications? So the first thing is the size has been reduced compared to the actual application that you have, right? So the size of the application, let's say if you're even if your phone is not having like they have to think of the people who is, let's say if Facebook or Flipkart is there, so they have to think of a people like where they have a user base like let's say 1 billion or something. In that case, they'll have half of the user who is not even having a phone with 8 GB of RAM or maybe 4 GB of RAM itself, right? Or maybe they'll not be having a phone with 64 GB of ROM or 128 GB of ROM, right? So in those cases, they need to actually go, they also need to grab those kinds of people or actually from all over the India where they don't see like they see that there are multiple users who don't have the resources to actually go on the real application that they have, but still they have a light feature like let's say a light applications where they can just go there and just download it from there, right? So let's say if I talk about, let's say, Flipkart Lite. So let me just see the Flipkart size. So the size of Flipkart is around, I guess, 100 MB or something, but if I go for Flipkart Lite, so I think they have 10 MB of the size of the application that you have. So these things is like when you have a lesser memory to consume, then it is fine. Like anyone can go with the application, then they can install it, right? Same goes with MLAI here. So instead of running a whole TensorFlow on a like how they are going to run TensorFlow or let's say any kind of ML applications on the device. So that is not possible with anything, right? Let's say if I am having if you are using ChatGPT, in case of ChatGPT, they cannot run their whole calculations or computation on your system itself because the computation power is too much that your battery will drain in maybe 5 minutes itself, right? The power consumption will be too much, then there will be too much of memory consumption, then there will be the latency will be very much high here, right? That means you will not get the accurate result as well if they use the real model to go with, right? But still they need to actually send the real data at the same time, right? Like the minute you enter some prompt, they have to give a real world examples or like whatever you give the prompt. So based on that prompt, they have to actually generate accurate, more and more accurate result, and it has to be it should not take more time. Like let's say if you are triggering something, so it should not take a like half an hour to do all the process and give you the result, right? S- So in order to do these things, nowadays we have like let's say example of Google Lens, or let's say example of like YouTube. This YouTube has launched some AR feature as well. So in these kinds of thing, they need to run their application on the device itself, right? So in order to do that, we have something called TensorFlow Lite, which is developed by the Google developers, right? So in I think in the last meet, if you were there, so in the last meet, Anushka talked about MediaPipe. So actually, MediaPipe is also built on top of TensorFlow Lite, because that is also a, like in TensorFlow Lite, you need to write, basically you need to write the code and do everything. In case of MediaPipe, you already have built-in models, and then you can just use those models to do whatever you want to do. So that was the introduction of TensorFlow. Like that is the actual reason that we need TensorFlow Lite. And now let's move to why TensorFlow Lite. So just now I explained, actually, like let's say if we have a model which is a high-end model, in those cases we need to run our applications on device itself. And like let's say if we want a higher let's say if we are expecting higher frequency in the request side, that means there is a higher user base on a particular application. In that case, it is actually not viable when you have a cloud service or something where from where you are fetching the data, or from where you are executing the codes. So it will be better if you compute the say all the things on the user device model itself. But the thing is, the models that we have, like in AI, if we have any model, so the model size is actually too much. Like in GVs, it will go, right? So how can we make it more and more sustainable that even a user with a simple smartphone itself, they can come, or we can try to compute all the things on the smartphone itself. So there comes TensorFlow Lite. Now, so the first thing, using TensorFlow Lite will have lower latency and close net interactions. So if we talk about on-device ML, actually, so on-device, we are talking about on-device running a model on the device itself instead of running the model on the cloud. So let's say if there is a multiple request is coming on the cloud, so server can give errors, like the accuracy can be lesser, or maybe if the accuracy is there, it will take the latency will be higher, right? It will take too much time to actually get the response back from the server, because because of the like request response cycle here, right? So there comes, if if it is possible that if we run an application be not no compromise, right? We cannot compromise with the accuracy here. So with TensorFlow Lite, even that can be like wait a second, yeah, even that can be rectified with TensorFlow Lite. Yeah, there will be some differences in the actual model and on-device model, because the computation power that a server has, it is not there in your system. It may not be there in your mobile devices, or like say desktop devices, right? So in that case, the accuracy cannot be like, let's say if accuracy is for some model, if the accuracy is around 98%. So it may be possible that when you go for on-device ML, the accuracy can decrease it by like 1 or 2% or something. Yeah, but it should not be like drastic change should not be there. Then there is other thing, that when you use on-device ML, the next thing that you have is offline availability. So even if the user has not connected with the internet, or even if the user has not been user is not been connected with the internet, so that means they don't have access to any internet services, like let's say cloud or something. So they cannot connect to any other server nearby, right? So in that case, on-device ML does one thing, that even if you are not connected with the internet, still you can actually do the like still that on-device ML can actually run the model and give you the result. Like if I take an example, so if you have seen Google Translator is there, or let's say Google Lens is there. So actually Google is in the sense I'm not talking about like it is going to search on Google, but when you just translate it, so the translation can be done without internet, right? Or let's say a simple example I can give you like even if you are not connected with the internet, so Google having this product called YouTube AR. So YouTube AR, or let's say on Instagram, you can use filters. So these things they have like there is a AI, right? But the thing is, since they have implemented it using just on-device ML, basically TensorFlow Lite or something, so they can run your model on the device itself, right? TensorFlow Lite is just that you can convert your model, whatever the model you have, just convert that model into TF Lite. That is it. It is not like creating a model using TensorFlow Lite. So we'll see that actually in the examples. But as of now, it will be like let's go with some background. Then we have privacy preserving. So that is also a main concern here. Like, let's say even if you are running a application on device itself. So if it is running on device itself, then it is not even the privacy is not even a concern here, right? Because all the things is there with you itself. Like the model is running on your system, right? So that is a better actually choice here. Now on-device ML allows for a new generation of products. Anushka, is it going okay for you? Okay. Asa, do you have any concern till now? Yeah, I think there is a new person here, Susma Gupta, right? Okay. So shall I continue? Okay. So, for basically, if I say so. Here, just now we have seen what are the advantages that we have if we are running a model on the device itself, right? But there can be some disadvantages that I talked about before that accuracy may not be as same as you are running on a real model, like the actual model. Okay, that can be one thing. But yes, if you are using TensorFlow Lite, it will try their best that it you get the exact accuracy that you are getting in the real model. Okay, so that is one thing here. There can be some kind of like let's say if there is 1 or 2% of uh, difference, then in some cases it doesn't matter, but in some cases it may give you a better result. Like let's say if it is a hospital application, so in case of hospital applications, the accuracy has to be, it cannot even like we cannot even expect it to drop by 1% also, right? That is not allowable for the application which is running for like human life, right? So yes, so that is a different part. But now the thing is, it has to be like the on-device ML allows for a new generation of product. So basically, even Google is trying to give you a better result. Like let's say if it is YouTube. So on YouTube, they're trying to actually implement something like where you can just come and let's say if someone is showing you a makeup kit there. So you can just come there and then just try it from there itself, from the YouTube AR as well itself. Okay, you do not have to actually go to the shop and then try it. So they are trying as that as well. Or let's say you might have seen uh, in some applications that they give you a feature called you can just open your camera and see that how that particular product fits in your room, right? That is also applications which needs to be run on the device. Even if you're not connected with the internet, it should work on the device, right? So those are some applications that we expect to come, or maybe it is already there, they are implementing it. So that is the future for on-device ML here. Okay, like so this is uh, this if we talk about TensorFlow Lite, so TensorFlow Lite is going to help us with these things. Now you can see Google Meet background blur and repress. So this is the example for on-device ML here. Like even if you're not connected with the internet, it can work on like the background blur and all. It is going to work even if you're not connected with the internet, and even if you're connected with the internet here. But the thing is, it will work because it will work much more efficiently because it is on the device. Like it is the implementation, the computation which is happening. It is on the device happening. Okay. So that is one of the example of TensorFlow Lite implementation. And since Google Meet is the like Google Meet is the product of Google, and TensorFlow Lite is the product of Google, that means they have used TensorFlow Lite in this implementation here. Okay. Now there are multiple packages, like there are multiple applications that where they have tried it. So if you know Nest, so in that also they have tried it. So package or person detection, hand gestures, stop sign. So they have all tried it on the Nest. There is a Google Nest, right? So on that they have tried these things as well. Like let's say if you want to stop a video, so you can just stop it by showing the hand that okay, stop it, right? Or you can just ask something from them. So those are the examples of on-device ML. Okay. Now, yeah. So this is the example of YouTube AR try-on. So they're just trying to like on the YouTube itself, you can just try these things here. Like you can just see the video here, how it is happening. So based on what shade you select, but it's just giving you okay, this is how you are going to look like, right? Is there anything till now from Asta or Susma? Do you guys have anything? Okay, great. Susma, I think you have connected before as well, right? Are you the first time or you have connected before? Okay, I remember it actually. Okay, fine. So, this is one of the example of the implementation of actually TensorFlow Lite, and actually not actually TensorFlow Lite here, but we are talking about sorry, on-device ML as of now, and that will be implemented using TensorFlow Lite. So this is it. Now, so how it works actually, like in the background, how does it works? So the simple thing is here, a model is at the core of an on-device ML solution. So how does that model actually work on the device itself? So yeah, so you can see, let's say the first thing, a particular user gets the input, or not a user here, the model. So the first thing, model, whatever it is there on the device, it just gets the input from the user, and then it will try to do some computation here. Okay, then it will try to give you some output here. So the thing is, in between this model inference, like in between this input and output, there are too much things that has to go on, right? So yeah, so here this model inference that you have, so because let's say if there is a model, so the first thing it has to like it has to first uh, like train itself, and then actually training will be done before, but the computation needs to be done, right? So the competition will be there. Then there will be some like accuracy test that like on which epoch that they are getting a better accuracy, right? So the minute they get a better and better accuracy, they'll try to give you the output, right, based on the performance that they have. So let's go for the next. Okay. Here you can see both involves much complexity that hinders fast development. So you can see here, let's say if there is an application like basically there will be some application like ML applications. So in this case, you can assume this live camera is basically the input, right? In between that, now you can see there are multiple things which goes on. So buffer management, subsampling, then data life cycle, image filtering, format conversion, timestamp extraction, resource caching. So there has to have so much of thing like what is the like the flow control, then data pre-processing, then there is a model, then post-processing, then synchronization, and at the end you're going to get the output. See, in between that there are so much of calculations which is going to go on, right? So uh, in between that there are multiple layers of like complexity which is there actually, and there are multiple layers of computation I can say, which has to go on. And the thing is, when it is running on your own device, it should not actually it should not damage your battery as well, right? So it should not damage your battery. It should not consume too much of like computation power from your system, right? So those things actually should not be there. But the thing is, if you talk about ML, so ML needs those things, right? But still, with the TF Lite, it can be reduced because it just tries to take as less space and as less computation power as it can, and gives you the better result. Now, okay, so on-device ML with TensorFlow Lite. So as of now, I'm having some solutions here, like just some examples here. Let me stop sharing this screen. Anushka, let me know whether my screen is visible or not. Okay. Okay. Now, yeah, I'll just try to open some tabs. Okay. I believe so. Can you guys confirm is it visible or not? Just a second. Yeah. Okay. Great. So see, there are some implementations. I just went to Kaggle and I just try to search it with some TensorFlow Lite ID. So there are some implementations like let's say Google. So Google is having this particular thing that is isolated sign language recognition. So this sign language recognition has to be on the device, right? It has to run on the device. So actually they had like competition of this, but as of now you can see like there are multiple sources here that is actually claiming that okay they have implemented TensorFlow, like they have created a model and created a TensorFlow Lite model as well that can run on the device itself, right? So here, I just went through this ISL recognition with transformers, and or let me actually use something else. Yeah, here. So here I am having an application that is object detection with TensorFlow Lite model maker. So how you are going to like let's say if you created a model, so remember to create a TensorFlow Lite model you need to have a model first, like the ML model has to be there. So the first thing is, so that means the first thing you need to do is first create a ML model, then you can convert that ML model to a TF Lite model, and then you can host it on, let's say if you're having an Android phone, or if if you're using Android development, or if you're using any kind of development, let's say if it is a website development or something, so there you can directly use that models. Okay. So So that has to done by TensorFlow Lite. But as I told you that before using TensorFlow Lite model maker, you need to first have a model. So that using TensorFlow Lite model maker, you can convert that particular model to TensorFlow Lite. So you can see here, let's say here are some supported tasks, like what are the tasks that they can support. So the model maker library currently supports the following ML tasks. So you can see image classification can be done, object detection can be done, text classification can be done, bird question answer can be done by TensorFlow Lite, audio classification can be done, recommendation can be done, or search can be done. You can see multiple tasks are there which is supported by TensorFlow Lite as of now. That can, let's say, if you have created a model, so you can just convert these tasks to a TF-Lite model, and then you can just convert it. Sorry, then you can just use that particular model into your application wherever you need it. There are other example as well. Like this is teachable machine learning with Google. If you click on get started, they also use like something like TensorFlow itself. So if I go here, what you can do actually, you can just, let's say if it is an image product or audio project or Roj project. If I go to image product, sorry, project, then you can just go here and you can see they have implemented export to TensorFlow or TensorFlow Lite or TFJS. So you can use anything here. So if I go here, here you can see what you can do just here. Just upload multiple samples here. Let's say if you are having multiple cat example, right? So in that case, what you can do, like we want to differentiate between cats or basically any kind of image classification. In that case, what you can do basically just upload all the classification, just rename this classes here. Let's say if it is something like roses, so you can just create like a roses, then you can create some other, let's say tulip. Then the same way you can just add more and more classes that you like, and then upload the samples here. Like let's say if you are having a data of 10 GB or maybe 1 GB or something, so you can just upload it here. Okay, and then you can just click on this train model. So the thing is, as of now I'm not having as of now something, so you can just click on this train model. So you can see epochs here. You can also set the epochs, batch size, the learning rate also. You can just set these things by yourself, and then the minute you click on train model, it will give you a model here. By default it will give you a testable light model. And then let's say as of now, if okay, I'll just try to do something that I'll just try to download some data from there. So animals data. Let me just write animals. Yeah, here it is. So there are 90 different image animals. So if I click on download, it is around 688 MB of files. Okay, let me just download it here. Uh, so I'll just try to download it. It may take some time as there are multiple uh, like animals here. So what I'll do, I'll just download it and try to use some less animals here. So I'll just wait for 1 2 minute. In that, if you guys are having any doubt, you can just ask me now. In this teachable, you are asking here, like you are asking about this teachable website, right? Asta, I didn't get you actually. Like, are you asking about this teachable website? If you're asking about this website, in here you can actually just upload images or videos actually, not the text. Because you can see here, right? Add image samples. So they have particularly written it here that you can use images here.
Hi, can you hear me? Hello?
Hello?
Yes, can you guys hear me?
Yeah, yeah, yeah.
Okay, sorry, there's a lot of background noise. I understand.
Actually, you were very like you are audible, but it is very less. The voice is very less.
How about now? Better?
Wait a second. Now can you try?
Yeah, can you hear me now?
No, you are not audible as of now. So it just loaded a sample. I'll just write zebra here because it is not rose. Uh, Asta, can you just do something? Just write in the chat box. No, it will be better. And I'll just try some other images. Let's say whale here because that is a different, very different thing. And then we click, yeah, and then let me try one more thing here. Uh, let's say all because again that is again a different thing. Oh, so now I'm having three classes here. In this class third, I'll again write it as all. And now let's try to train the model. So what we can do the next, just try to train the model. I'll just use 50 epochs so that it can take some less time. Or because we don't have that much data anyway, so it will take very less time. Okay. Oh, so while it is training, we should not switch the tab as well. Yeah. So now you can see actually, do you? No, as of now, I don't want. So now I can just try to export the model, or let's say there are outputs like zebra, whale, or owl. So what I can do, I can just use file here actually, not the e. And then I'll just try to add something. Let's say parrot. So I'll just try to take a image from here and try it. So if it is okay, so for parrot it is identifying it as a all, right? Which is actually a bad thing here. If I say, let me just try to go with lizards. Let's see what it is identifying. So For lizard, for this particular icon, so you can see, sorry, for this particular image, because there is some like there are some lines here, so it is just identifying zebra as somewhat, and then whale adds some more percentage of it, and then owl as some lesser percentage. So this is our training model, actually, which is not actually trained as much as we want to. Let's say if I just write 100 or something, in that case, let's say if the accuracy is getting higher or not. And since we don't have that much data actually, like just 16 samples of data we have, so we cannot actually see that it will give you a maximum output here. So I'll just try to do something here. Let's say now if I take this particular lizard here, yeah, so now it is taking whale as like instead of lizard or something. Or let me go with something like cat here. So I believe the cat, let's see, yep. So it is more taking it as a owl instead of zebra. So zebra is taking because of the lines which is there. So again, the more you train it, the more you have the classes here, the better it will give the result, right? So if I just export the model now, so I can export it into TensorFlow.js or TensorFlow or TensorFlow Lite itself. So I can now download my model from here, let's say floating point or quantize or HDPU. So whatever I want to do, I can just convert it there, and then I can use it anywhere. Let's say if it is an Android, so I can just download it and then use it in Android. There is a application like there is from Google itself. We have a framework like Flutter, right? So in that itself, Flutter actually supports TF-Lite. So we can use this model inside Flutter itself if we want to, right? So by downloading this model, we can try to check what is the like accuracy of this model that we have. So there are multiple things. So as of now, we have one thing that we have done is image classification, right? We can also do object detection with this. So there are multiple things that we can do with TensorFlow Lite. Like there are multiple examples of this. Actually, they have this recommendation model here that is like a recommendation model here. They are just trying to create based on what movie a particular user is watching. They are trying to give a recommendation based on the movie that they have watched already. They have watched. So this is one of the recommendation model by the Google actually. So you can just go ahead with this. Let's say Android example is there, download a starter model is there, training code is there. You can just go with, let's say if I go to Android example, so we have the code for Android and then we can just try it. So is there something now?
Yeah, can you hear me now?